Hello everyone, welcome to the Tech Study channel. Here you get notes and explanation of B.tech related topics, and in future I will include M.tech related topics also. And in this video we are discussing important questions of elements of electrical and electronic subject, which is Triple E. So these are some important questions. First one is draw neat circuit diagram and explain the working of semiconductor diode and VI characteristics. And second one is what is rectifier, explain circuit diagram of full wave rectifier. What is Zener diode and draw its characteristics also. And explain the operation of CE, means common emitter characteristics briefly. Explain the biasing networks in BJT, bipolar junction transistor. So in this video we will see first important question and its answer. So here, what is semiconductor? Semiconductor semiconductor diode means when a p-type semiconductor is suitably joined to n-type semiconductor, the contact surface is called semiconductor diode or PN junction. And then we will see working of PN junction. Here p-type semiconductor have negative acceptor ions and positive holes, and n-type semiconductor have positive donor ions and negative electrons, free electrons. So negative acceptor ions means which it accepts electrons and becomes negatively charged, and positive donor ions means it donate extra electrons and becomes positively charged. So here the definitions are we are done. So the tendency of free electrons to diffuse over p-type and holes over n-type is called diffusion. The tendency of free electrons to diffuse over p-type and holes over n-type is called diffusion. Okay, then here, when electrons move across junction from n-type to p-type, the positive donor ions are removed by the force of electrons, and positive charge is built on n-type of junction, and similarly negative charge on p-type of junction. So when sufficient number of positive donor ions and negative donor ions are gathered at junction, this is also called potential barrier. It prevents diffusion of charge carriers. And the positive charge on n-type repels holes to cross from p-type to n-type, and negative charge of on p-type repels electrons to cross from n-type to p-type. The potential barrier is of the order 0.1 and 0.3 volts. The depletion layer is formed quickly due to near the junction the region is depleted, means emptied of charge carriers, electrons and holes, due to diffusion across junction. It is thin as compared to N and P type materials. And the positive and negative charge creates electric field as shown. Here it will create positive and negative charges will create electric field here. The electric field is a barrier to the free electrons on n-type. For these electrons, it is act like a barrier. The junction means this whole thing is called junction. Okay. This is the junction, and this is the p type, n type and junction area. Okay, the potential difference across depletion layer is called potential barrier. The potential difference across depletion layer is called potential barrier, which is denoted by V0, which is dependent on several factors like type of semiconductor, and amount of doping and temperature. So for silicon, V0 is equal to 0.3 volts, and for germanium, V0 is equal to 0.7 volts. PN junction in forward bias. So when the external voltage DC is applied across the junction in such a direction that cancels potential barrier and permits current flow in, is called forward bias. Listen carefully. The external voltage DC is applied across the junction in such a direction that cancels potential barrier, which is developed here. Here it is developed now. Electric field is developed, and also sufficient number of negative acceptors and positive donors are gathered here now. So this is called potential barrier. So this permits current flow, is called forward bias. The P terminal is connected to P type material, and N type terminal is connected to N type material. Means this is positive terminal or P type terminal. This is negative terminal or N type terminal. Okay, not type, N terminal. This is P type material, this is N type material. The forward potential establishes electric field that acts against field due to potential barrier. The field due to potential barrier. Here I wrote repeatedly. So here the forward potential establishes electric field that act against field due to potential barrier. This is not there. And height means width is reduced and weakened, and a low resistive path is established. Since the potential barrier voltage is a small voltage, 0.1 to 0.3, only small forward voltage is needed to completely eliminate potential barrier. Due to decreased potential barrier, the current flows in entire circuit. This is called forward bias. The magnitude of current is depends on applied voltage. Here PN junction in reverse bias. When external DC voltage is applied across the junction in such a direction that increases the potential barrier and restrict the current flow, called reverse bias. The N terminal is connected to P type and P terminal is connected to N type material. Okay. Here the negative terminal is connected to P type and positive terminal is connected to N type material. The reverse potential establish an electric field that act as the same direction as field due to potential barrier. The field due to potential barrier is strengthened and width of barrier is increased. A high resistive path is established due to increased potential barrier. The current does not flow in entire circuit, called reverse bias. Then we are looking into VI characteristics, the curve between voltage across junction and circuit current. It's called VI characteristics. The voltage are on Y axis and current on X axis. So here is the curve, here is the potential barrier, and here breakdown voltage. Then by using Shockley diode equation, ID is equals to Is of e to the power of kVd by t minus 1. When the junction is off, when Vd is equals to 0, Vd means external current and Vd means external voltage and Id means current through Vd means external voltage. Okay, Id is equals to Is of e to the power of 0 minus 1. Here we are substituting Vd value. So e to the power of 0 means 1, 1 minus 1 0, 1 I into 0 0, Id is equals to 0. In forward bias, Id is equals to Is of e to the power of kVd by t minus 1. Here on Id, Is is dependent and Id is equals to external current, Is is equals to internal current. Okay, in reverse bias, Id is equals to Is into whole e to the power of kVd by t minus 1. Vd is equals to negative voltage. Then e to the power of negative means 0 point something. Then Id is equals to Is of minus 1. So Id is equals to minus Is. If Id increases, then Is decreases. If Id decreases, then Is increases. That's it for this today's class. In the next class I will explain remaining questions with answers. Okay, if you have any doubt, ask me in the comment section. Bye.